f of x is equal to ln of 2x plus 5 for x belonging to real numbers such that x is bigger than a. It's represented by this graph here. State the value of a, find the value of b such that f of b is equal to 10, find the function f to the minus 1 of x, which is the inverse function, stating its domain, and then sketch f of x and f, the inverse function, on the same axes. So, here is the graph. We first of all have to find the value of this vertical asymptote here. Well, if x is greater than a, the bit here in the logarithm, 2x plus 5, cannot be equal to 0. It always has to be positive because you cannot take the ln of 0. So 2x plus 5 must be greater than 0, which means that 2x must be greater than minus 5, and x must be greater than minus 5 over 2. So this line here is x is equal to minus 5 over 2, so it means that a must be minus 5 over 2. Now we have to find the value of b such that f of b is 10. So basically, this value of b gives a value of 10. So f of b is equal to 10. So that means at x is equal to b, ln of 2 times b plus 5 must be equal to 10. Now, log to the base a of b is equal to c implies that a to the c is equal to b. Now this is fundamental, being able to go from this to this and this to this when using logarithms and exponential functions. So the base here is ln, so it's base e to the power of 10 is equal to 2b plus 5. And you need to be able to transpose things like that. So e to the 10 is 2b plus 5. Let's write that out again. Therefore, e to the 10 minus 5 is equal to 2b. And therefore, b will be e to the 10 minus 5 divided by 2. That's the exact answer. To find the inverse function, if we let y be equal to ln of 2x plus 5, what you must do is rewrite this so that we've got x is equal to. So we'll make x the subject. So c will be equal to ln of log to the base a of b implies a to the c is equal to b. So we're using that yet again. The base is e. So we've got e to the y will be 2x plus 5. So subtracting 5 from both sides, we're going to get e to the y is minus 5 is equal to 2x. And then we're going to get x is e to the 5 minus e to the y, minus 5 divided by 2. Therefore, the inverse function is e to the x minus 5 over 2. Now, the domain of e to the x, you can put any value of x into e to the x. So the domain will be all the real numbers. And we should also know that minus 5 over 2 will be a horizontal asymptote, which we'll see in the next graph. Last part, you're asked to draw both graphs on the same axis. So this is the original graph. These are the axes, and the axes really need to be equal aspect. So if this is a vertical asymptote for the original graph, then this line here, y is equal to minus 5 over 2, will be a horizontal asymptote. So basically, everything is just reflected in the line y is equal to x. So this graph here becomes this graph here. We can find some points on the axis. Let's take that point there, for example. At that particular point, ln of 2x plus 5 is equal to 0. The y-coordinate here is 0. And therefore, if we use log to the base a of b is equal to c, then we can rearrange this as 2x plus 5 is equal to e to the 0. E to the 0 is 1, so 2x plus 5 is equal to 1. We get 2x is equal to minus 4, therefore x is minus 2. So this point here is going to be minus 2, 0, which means that this point here will be 0, minus 2. This point here is when x is equal to 0. So when we put x is equal to 0, this we're just going to get ln of 5. So this will be 0 ln of 5. This point here will be ln of 5 comma 0. So this has been a video to show you how to manipulate logarithmic functions and find their inverse and understanding of their graphs. I hope you've understood, and I thank you very much for watching.